everyone, we're going to take a look at a data set that involves instructor salaries and several other characteristics describing instructors at a higher educational institution. Our goal in this lesson is to build the components of a multiple regression model. That is, a model that will predict a dependent variable based on a combination of what we would call predictor or explanatory or independent variables. All of those terms can be used interchangeably. So in this case, we will be aiming to try to predict the instructor salary based on years of service, whether or not they have a PhD, articles, and gender, male or female. So let's take a look at what a multiple regression model would look like in the abstract sense for a problem like this. The multiple regression model has a lot of terms in it, but if we break it down, it's quite similar to what we would see in the bivariate regression model. We have an intercept that's represented by beta 0. And then we have not just one slope, but multiple slopes or coefficients that quantify the change in the dependent variable, predicted dependent variable, for each unit increase in the predictor variable or independent variable. So for example, let's just take a look at two of these. Beta underscore years, right? So beta, for the years variable is measuring the change in the predicted salary for each additional year of service. We would expect that value to be positive, right? We'd expect that for each year of service, an instructor can expect to make a slightly higher salary. Then we have another combination here, which shows the beta for PhD multiplied by the PhD variable. This beta, this coefficient, tells us the change in salary, the change in predicted salary, depending on whether or not an individual has a PhD. So this being an indicator variable, not a continuous variable, we interpret it slightly differently. So depending on what this number is, we would also expect it to be positive. And we would expect 1 to indicate that somebody does hold a PhD. That number is going to tell us how much more money an instructor can expect to be paid if they do have a PhD. So that's how we'd interpret the coefficient for an indicator or dummy variable. All right, let's take a look at the statistical output. The statistical output for a regression analysis looks more or less the same regardless of what kind of software you're using. So this is Excel, but if you were using, say, Minitab or R or Python, the format of the output is going to be organized in more or less the same way. And the first thing we want to do is build the model using the actual values of the coefficients. Okay. So we can see that that is written out down below the statistical output. So where it says model, we have predicted salary is equal to 12,739.4. So that's the intercept of the model. And then we add the next term, which is the coefficient for years, which is 1,045 times years, plus 1,462 times PhD, and so on, right? Notice that the coefficient for gender is negative, and we'll talk about that in a second. So interpreting a coefficient in context, let's just do two of them. We could say for the coefficient for articles, for example, that when all other variables are held constant, the model predicts an increase of $543 in the mean salary for each additional article. Okay. So basically, if an educator or an instructor, faculty member is publishing more, they can expect to be paid more. Let's interpret the coefficient for gender, when all other variables are held constant, the model predicts that female educator will make a salary that is below that of male educators by 1,266. So those are two examples of interpretations of coefficients in a multiple regression model. Let's take a look at how this model could be used for prediction. If we look at one row of data in the data set, we could calculate the predicted salary given the values of all of the predictor variables. So what we have is 35 years of service, a yes for PhD, 18 articles, and the gender would be male, since it's a 0 here. So to predict the salary, we would plug in these values into the regression model that we just wrote above. And this calculates out to be 60,560. Okay, so that's the predicted salary for this particular individual. Notice that the negative 1,266 actually was not factored in because we multiplied by 0, right? So because this person is male, they actually make $1,266 more than females. So we don't have that subtraction that we would have if this person were a female gender. The next thing we have here is a calculation of a residual, which is a good thing to know about. A residual is a measure of basically prediction error. It tells us the difference between the observed and predicted values of the variable that we're trying to predict, our dependent variable.